Chapter 5, Section 7 is about scatter plots and trend lines, and we want you to be able to understand what a trend line is and what lines of best fit are and how to use them. So we're going to start with our first vocab word, which is scatter plot. A scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. Okay, the two different sets of data would be our x's and y's, and they're going to plot them on a grid just as points. Generally, they're not going to make a straight line. Okay, and also they're usually going to be all in the first quadrant because they're going to be positive points of data. Now, there's three different possibilities in correlation. That's what they call it. So if you look at this very first one, if you notice, all the dots are kind of heading up to the right, pretty close together. They call that positive correlation. The second one shows that they're all kind of heading down to the right. That is negative correlation. And then in this last one, there doesn't seem to be any kind of pattern. I couldn't draw a line through them to show where they're going. This is called no correlation. Okay, we're going to start just by creating a scatter plot. We're going to use this table down here that shows the altitude of an airplane and the temperature outside the plane. We're going to create a scatter plot and then figure out what kind of relationship it has, meaning does it have positive correlation, negative correlation, or no correlation. All right, so remember that when I have a table, this is just like my x and y, and these are my ordered pairs. All right, so I'm going to start by putting a dot at each ordered pair. So I'm going to go over 0 meters up 59 degrees. That's right about there. Then over 500 up 59.2. So we're pretty close to there. Then over 1,000 up 61.3. 1,500 55.5. 2,000, it's me 41.6 degrees. 2,500 is 29.8. 3,000, 29.9. 3,500 is 18.1. 4,000 is 12.4. And 5,000 is 0.6. Okay, now, even though these don't make a straight line, I would say that in general, I could draw a line through like this, and that would be negative correlation. Okay, now think about this situation. Consider the population of a city and the number of letters in the name of that city. Would we expect to have positive, negative, or no correlation between these two sets of data? How are these two related? So this is what we're going to think about. We're going to think about the town of Albertville. Okay, Albertville. And then the population. I don't actually know the population of Albertville, but what they're saying is the number of letters in the name of the city should matter. So if I took away a letter in Albertville, is that going to make people leave town? Is that going to make our population also go down because I took away a letter? My guess is no. If I added a letter, is that going to make the population of our city go up? No, probably not. So I'm going to say that this has no correlation because those two things are not related in any way. Okay, next three vocab words. We have a trend line, which is a line that you can draw near the points to show your correlation. That's that line that I've been drawing through all the dots to just kind of show where they're headed and to show what kind of correlation that they have. Interpolation is when we estimate a value between two known values. So a value that's in between some of the data points that we already have. Extrapolation is when I use that data that I have to predict something outside of the data that I know. Okay, so maybe I'm trying to estimate something in the future. That would be extrapolation. Okay, think of interpolation like inside, extrapolation like extra, something I don't already have. Okay, we're going to try making one of those trend lines and writing its equation. Make a scatter plot of the data below, draw a trend line, and write its equation. Use the equation to estimate the deer population in the 12th year. Okay, so this table shows us the deer population in 8 different years. Okay, first thing we have to do is we have to actually plot those points. So the first year, the population was 1,260. If you notice, I had to use the little lightning bolt right here. That's because I didn't have enough room to get 17,000 deer population on this side, so I used that lightning bolt to show that I skipped a huge chunk and then started counting by even increments. Okay, the second year we had 1,375. Third year was 1,310. Fourth year was 1,490. Fifth year was 1,625. Seventh year, 1,740, which is actually up here. And the last year, 8th year, 1,715. All right, I actually think that this second one could probably move a little bit up to here. Okay, so if I draw what I would call my trend line, means I'm going to try to go through a couple points on my way. We're going to see what I can do. Okay, but I also want to get it through the general area of where everything is headed. Okay, so in this next slide, I'm going to show you how to do the next part. We've done the scatter plot, we've done the trend line, now we have to write the equation. Okay, the first thing we're going to do is you're going to estimate or choose 2 of the points that actually landed on your trend line. So I'm going to use this one, which happens to be that ordered pair, and this one, which happens to be this ordered pair. Okay, so that was 1,260, and 4, 1,490. All right. I'm going to create an equation in point slope form because now I have 2 points and I can use those to find my slope, which is the first step here. This would be x1, y1, x2, y2. I'm going to use that to find the slope for my equation. So I have 1,490 minus 1,260 over 4 minus 1. Okay, so when I do 1,490 minus 1,260, I get a 230. And I could simplify that. It's not going to give me anything super nice. So I'm just going to leave it. Okay, then when I write so this is my slope. So when I write my equation in point slope form, I have to choose a point. I'm going to choose this one just for ease. So it will be y minus 1,260 is equal to my slope times x minus 1. That's where I get to leave my equation. Now I can actually use that equation to answer their final question, which was what we need to estimate the deer population on the 12th year of the study. Okay, if you notice, year was our x value. So we're going to go back to our equation here, and we're going to plug in for the x. We're going to plug in a 12. So we have y minus 1,260 equals our slope times 12, because we're looking for the 12th year, minus 1. Okay, well 12 minus 1 is 11, so I'm going to just change that right away to an 11. Okay, then on my calculator, I'm going to take my slope times 11, which gives me y minus, this is just an arrow, y minus 1,260 will be equal to 843 and a third. And I'm going to add this 1260. Okay, Okay, and that tells me that my deer population on the 12th year will be about 2,103 because I can't have 1/3 of a deer. So we're going to say it's about 2,103, which actually fits our data. 2,103 on year 12. See how it keeps growing. Okay, that's called extrapolation because I used the information that I had to estimate something outside of my data. All right, you should be able to complete page 338, numbers 7 through 10, and lesson quiz numbers 1 and 2.